Practice Exam 1, Version D. Pause the video while you read the question. The atomic mass on the periodic table is a weighted average of the naturally occurring isotopes and their relative percent abundance. In general, atomic mass is calculated according to the following equation. A little note: when percent abundances are used in these calculations, they must always be converted to their decimal value. To convert the percent abundances into its decimal form, divide by 100. That is why the percent abundance of the isotopes can be regarded as fraction because of its conversion into its decimal form. In this problem, by using the given mass of the two isotopes and the average atomic mass of antimony from the periodic table, we can insert those into the equation. The percent abundance of the naturally occurring isotopes of antimony will each be different. X represents the percent abundance of antimony 121, and Y represents the percent abundance of SB 123. In addition, the sum of the percent abundances equal to 100%. Therefore, to use in the calculation, we have to convert it into its decimal form, and it becomes X plus Y equals 1. We get 1 because of 100% divided by 100. Now, plugging it all into the equation, we have X and Y over in its right place to represent the percent abundances of the isotopes. Now, as you can see, we have to calculate using like terms. So, we have to manipulate this equation and either solve for X or Y in the calculation. Now, use X equals 1 minus Y to solve for Y, or use Y equals 1 minus X to solve for X. It is your preference, but in this case, let's solve for X first. So we will be using the latter, this part. Y equals 1 minus X. Plugging it all into the equation to compute for X the percent abundance of antimony 121. And remember to use the distributive property here in this part. We have 1 times 122.90 AMU and negative X times 122.90 AMU, which is shown here. And now we have found that X is 0.55 or 55%, which is the percent abundance of antimony 121, the lighter isotope. This is not the right answer because we want the percent abundance of the heavier isotope, which is antimony 123, and it is represented by the variable Y. Since we know what X is and the sum of the percent abundances equal to 100%, we can find what Y is by subtracting 55% from 100%, and we get Y equals 45%. We finally found that SB123 has a percent abundance of 45%, and as a result, choice B is the correct answer. Notice that the average atomic mass of antimony from the periodic table is determined by the more abundant antimony 121 with a percent abundance of 55%. In other words, the mass that is closer to the average atomic mass of antimony in the periodic table will have the higher percent abundance compared to the heavier isotope with the lower percent abundance.